Hey guys, welcome back to chapter 12. In this video, we are going to talk about how we determine if that t-value is high or low, and exactly what that t-value is. So in the last video, we looked at 4 different scenarios and trying to predict what the sign for delta G would be. So we looked at the scenarios where the signs for enthalpy and entropy were different. So enthalpy was negative, entropy was positive. And what we found is that these reactions will be spontaneous at all temperatures, always spontaneous. Then we looked where enthalpy was positive, entropy was negative, and in this scenario, we saw that they were never spontaneous. They were always non-spontaneous, no matter what the temperature is. So first 2 scenarios are not temperature dependent. Then the last 2 scenarios where the signs of enthalpy and entropy are the same, that's where we had kind of like conflicting things happening on both sides of this equation. So we saw that these were temperature dependent. So at low temperatures, something would happen. At high temperatures, something else would happen. So how do we define a low temperature or a high temperature? Well, it's reaction dependent. It depends on the particular reaction that we're talking about. So let's take a look at an example of how we can determine what's high and what's low. And specifically, we're actually going to determine the temperature at which this switches. So if it's spontaneous at low, non-spontaneous at high, well, what's this line right here? What's this moment that it switches over? So here's the problem that we're going to talk about. We want to determine what temperature, if any, that this reaction becomes spontaneous. So we need to figure out what that moment is where it changes from non-spontaneous to spontaneous. So let's think about the different scenarios. Spontaneous means that delta G is a negative value. Non-spontaneous means that delta G is a positive value. So what's that moment that it goes from spontaneous to non-spontaneous? Well, that moment would be when G equals 0. So what we're going to do to solve these problems is we are going to do this exact thing. We are going to set delta G equal to 0. Then we will be able to make the statement that above this temperature, this happens. Below this temperature, this happens. So in this scenario, determine what temperature this reaction becomes spontaneous. We would say, well, at this temperature, G is 0. Below or above, that's when it becomes spontaneous. So let's take a look at that equation and see how what this is going to look like. So our equation, remember, is delta G equals change in enthalpy minus temperature change in entropy. So in this scenario, we are going to solve for temperature. This is the variable that we're solving for. So if we're solving for temperature, we must have a value for all of the other variables. So let's take inventory here. So we said we're setting delta G equal to 0. So we want to know that moment which it changes from positive to negative. So 0 is that moment. We have our enthalpy change, and that is 95.7 kilojoules. We're solving for temperature, so that's what we're trying to determine. And then the entropy change, remember this is one of those wonky things, is given in joules per Kelvin. So I want to make sure I change this to kilojoules. And again, if you prefer to change enthalpy to joules, that's fine. I just typically go to kilojoules. That's just my preference. Okay. All right, so now we've got all of our variables in their correct format. Now we need to plug it into the equation. So we've got delta G is 0 equals 95.7, sloppy, 0.7 kilojoules minus temperature times 0.1422 kilojoules over Kelvin. All right, so to solve this, I'm going to move this whole variable to the other side. To do that, I'm going to add, so that's the inverse. So add this to the other side. I go to a new slide to kind of clean it up a little bit. So when I added that over, I ended up with T times 0.1422 kilojoules Kelvin equals, and then what's left on that side is just enthalpy. 90, I forgot the number, 95.7 joules. Just kilojoules. All right, so to get temperature by itself, I'm going to do the inverse. I'm going to divide by 0.1422 kilojoules over Kelvin. Whatever I do to the left side, I also have to do to the right side. So on the left side, all we have is T. And then notice our units here. I've got kilojoules on the top, kilojoules on the bottom. I'm left with just the unit of Kelvin, which is good news because we're solving for temperature. Let me grab a calculator. All right, so plugging this into my calculator, I've got 95.7 divided by 0.1422 equals, and it comes out to be 670, we'll say 3. Okay. So we determined the temperature at which this goes, the temperature at which delta G is 0, right? So we determined kind of that moment that it goes from spontaneous to non-spontaneous. Okay. So this is negative, this is positive, and we determined right here, this line happens at 273 Kelvin. So the problem wants us to determine at what temperature does this become spontaneous. So now we have to tell the viewer, is it above that temperature? Is it below that temperature? So going back to our table, we are in this positive scenario. So our enthalpy value is a positive number. Our entropy value is a positive number as well. So in this positive scenario, it is non-spontaneous at low temperatures. It is spontaneous at high temperatures. So if this is the moment that it changes, and we just determined this is spontaneous at high temperatures, the answer would be above 673 Kelvin becomes spontaneous. So that would be the answer to get all the points for that one. So we set delta G equal to 0. We determine the temperature at which this changes from spontaneous to non-spontaneous. Then we go back and look at what scenario are we in. So is it high temperatures that makes it spontaneous? Is it low temperatures that makes it spontaneous? We'll do some more examples of this, but I hope you guys found that helpful.